So with all that on the board, let's start 4-6. So 4-6, we're going to get into factoring again, but specifically we're going to factor quadratics. What are quadratics? How many terms do quadratics have? How many?
4.
You would think 4, because you hear quad, you think 4. But a quadratic does not have 4. Quadratics are what? 3 terms. Quadratics are things that are x squared plus 2x plus 7, stuff like that. So it's actually a trinomial. Okay, we have monomials, binomials, and now we're looking at trinomials. So things with 3 terms, we're looking at quadratics. Yeah?
Should it be called quadratics because it has a, x, b, and c?
You know, it's a great question. Anybody know? I don't know the answer to that. Why are quadratics called quadratics? Like cubics are x to the third. They're called cubics. That makes sense. Cube is to the third. Anything to the fourth is called a quartic function. Why is second called quadratic? I actually do not know. Maybe you could search to find the etymology. It's a great question. I'm not going to lie to you and tell you I don't know that one. I don't know. Cubic is for cubes. Quartic for 4. But why is quadratic x to the second? You got it?
Quadratum is the Latin word for square, and like square.
There you go. Quadratum for square. And that makes sense. A quadrilateral, the most perfect quadrilateral is a square. So there comes, is that Latin or Greek? Latin. Hey, Latin. You guys should ask Father Seller. He would have. Maybe not?
Quator is the Latin word
For 4?
Yeah.
Quator. Which is why quartic is probably 4th. And then, what was the other one? Quadratum. Quad. All right. So we've got 2 cases here today. We've got case A, where the A value, or case 1, where the A value is equal to 1. Again, we've got the first scenario where there's a 1 here. Second scenario where there's not a 1. How many of you feel comfortable factoring this because you've done it already? How many of you factored something like this before? I think most have done this in middle school. How do you feel with this? Meh, right? It's a little tougher. Have you done it with trial and error, where you just do 3 and 5 or 1 and 15 as your factors and just try numbers? You can do it. Trial and error is not a great thing to do. If I teach you a method, I call it the AC method. It's also like the inverted box method. Some of the teachers use different names and different ways to show it, but it's the same thing. So I'm going to show you how to do this with what's called the AC method. This one is a lot easier. Here's the question you have to ask yourself. Find numbers that sum up to B and multiply to C. So what numbers can add up to 5 that also multiply to give you 6? What numbers add up to 5 and multiply to 6? 5 and 1? 5 and 1 add up to 5? That's the common mistake. You did it the other way around.
Yeah.
Redeem yourself.
Add up to 5 and multiply to 6. 3 and 2.
3 and 2. So those go here. That's the simplest way to do all of these problems. Yes?
Can you also make it -1 and 6?
But those would multiply to give you -6. And we have +6 on the end. See that? But that's another way, yeah. So if we had, take a look here. If this had been a negative, then the answer would be -1 and +6. Okay, again, the question is this. What multiplies to give you C and adds up to B? That's always the question you're asking yourself. And then you simply put your signs here. Why are they both positive? Why is it +3 and +2?
Because you have +6 and also because the first 2 terms are positive.
When you add up to something that's positive and multiply to something that's positive, they got to be both positive. What if this had been, take a look please, what if this had been a negative here? Kate? Both negative. -3 plus -2 would give you -5, and -3 times -2 would give you +6. You see what I'm saying? George?
Why does it have to add up to 5? Like, because when you FOIL, you don't add 3.
Sure you do. You absolutely do. FOIL, you get x squared plus 2x plus 3x plus 6. George, I'm glad you asked that though, because I should show this. Look, this is why you do the add part. Again, look, when you FOIL it out, 2x plus 3x, doesn't that give you 5x? That's why these numbers need to add up to 5. So I don't even FOIL when I do math now. Whenever I multiply something like this, I do it all in my head. I say x squared, and then it's 3 plus 2, that goes right here. So I don't even show this step usually. Okay, but that's why they add up to 5, and 3 times 2 gives you the FOIL part for 6. Okay, I'm glad you asked that. I should show that next time. I'm kind of assuming prior knowledge. I shouldn't do that automatically. So that's the easy part. Agreed? Yes? No? Maybe? Okay, I think it's the easy part. Let's go to this example now here. AC method. AC method is something that I call AC method. I don't know if any other teacher uses that name. The reason I call it AC method is because you start by finding the product of A and C. What's the product of A and C in this case? What is it? 60. A and C is 60, right? A times C, that's 15 times 4. They're both positive. That plays a big role. Okay, so it's positive 60. If this is the case now, what I'd love for you to do is no longer find numbers that add up to B and multiply to C, but find numbers that add up and multiply to this number here. What are numbers that work that multiply to this number here, and add up to your, whatever your middle number was in the beginning? Instead of using C, use 60. So there's nothing that's going to multiply to give you 4 and add up to negative 16. Right? Do you see that? Nothing can multiply to give you 4 and add up to negative 16. But ask yourself, what multiplies to give you 60 now instead and adds up to negative 16 still? Any numbers multiply to give you 60 and add up to negative 16? Negative 10 and negative 6, does that make sense? Negative 10 times negative 6 gives you 60. Negative 10 plus negative 6 gives you negative 16. I know this sounds weird. You're going to be like, that's not the answer. It's not. It's absolutely not the answer. But you want to jot that down real quick, and I'll show you why. Here's what you do. The next step is to take that middle term and break it into those numbers. So start with the others the same way. Okay. We leave 15x squared alone. We leave the 4 alone. Take the negative 16 and break it into negative 10x and negative 6x. In either order, it doesn't matter. Like that. Make 4 terms. And now what method do you think you might use to factor when there's 4 terms? 4 terms told you to use what method of factoring from last class? Factor by grouping. So all you got to do for these problems. It works every time now. Forget trial and error. Because you can sit there all day and try 3x and 5x and 15x and 1x and try numbers to work. What I'm saying is, if you put 3x here and 5x here, yeah, that's how you get 15x squared, but then you got to try tons of different numbers. It might be messy. If you can do it quick that way, by all means do it. But this is a guaranteed correct solution every time. If I switch 10x and 6x, does it matter? We showed this last time. I think it was Max. Max, last time you had your order of these in different order, right? Remember it was the RW problem? And he had the order switched. But it was still the same answer, right? So it doesn't matter what order. Just factor by grouping. Bridge, GCF.
The GCF of those two would just be 5x.
Very good. Hannah, GCF. Why did you take out negative 2 and not just 2? Yeah, so what's left over? Go ahead, tell me, Hannah.
3x minus 2.
So Hannah took out the 5x. And remember, please, if you forget how to do this, take what you've got right here in your mind, divide it by the GCF. 15x squared divided by 5x is 3x. Negative 10x divided by 5x is negative 2. If this is 3x minus 2, Hannah just mentioned that this needs to be 3x minus 2. So if you didn't know what the second GCF was right away, that's okay. Maybe you didn't know what it was, so in the way you approach this, you don't have this answer written in. And you start with the second part like that. And then you ask yourself, what needs to come out of here to make this a positive 3x when I have a negative 6x to start? That's where the negative 2 needs to come out and divide out. And if you take a negative 2 out of here, this becomes negative 2. Okay, so this becomes, again, negative 2 there. So now that 3x minus 2 is common amongst both, take it out. And when you do that, you're left behind with 5x minus 2. Okay, that's our answer. So again, you could have tried 3x and 5x and tried to use a bunch of different numbers. This could have been, ready? 4 and 1, 2 and 2. This could have been 3x and 5x, 1x and 15x. you have, it looks like 16 options right there off the bat. So trial and error is, yeah, it'll work, but it takes an unlimited amount of time depending upon how many options you have, right? And some problems are going to get much tougher when you have more options to choose from. For example, if this, instead of 4, if this here were a number like 16, I could do 8 times 2, 4 times 4, 1 times 16. If this was 24, it's insane. 1 times 24, 2 times 12, 3 times 8, 6 times 4. Do you want to try all those? No, you don't. So AC method is a guaranteed working solution, provided that the original function or the original expression can be factored. If it can't be factored, AC method isn't going to work because it just can't be factored. So I'm not saying this is going to work every time, but it will work every time for all problems that are factorable, okay, or able to be factored. First one on your own. What multiplies to negative 28 and adds up to 3? What are the factors of negative 28? I'm thinking right away. 14, 2, 7, 4, and 128. Which of those can give you 3 somehow? 7 and 4 can somehow give you 3, right? Do I want it to be a positive 3 or a negative 3? So let's make 7 the positive one, right? And if I make 4 negative, doesn't that work? 7 and negative 4 give you 3. 7 times negative 4 gives you negative 28. So when in doubt, start by factoring whatever the C value is. Come up with a list of factors. See which one of those lists of factors with the appropriate plus or minus signs can give you the B value. You know that these signs have to be opposites because you have a negative 28. So one has to be positive, one has to be negative. AC method. AC is negative 24. What numbers multiply to negative 24 and add up to negative 10? Start with your factors of negative 24. This is where it gets annoying. Remember I was saying this before? 1 and 24. 2 and 12. Oh, what should I do, Bridge? When I get 2 and 12, what should I do right away? Should I keep going?
Yeah.
I shouldn't. Why should I stop here, Annette?
Because negative 12 and positive 2 add up to negative 10.
Yeah, make this negative.
Make 6 and 4. That's why.
But 6 and 4 both got to be positive to get 10, right? Or both negative to get 10. And 6 and 4, to give you this, have to be opposite signs, don't they? So the way 6 and 4 works is if they're both positive or both negative, though multiply to give you a positive, we have a negative. So we have to use positive 2 times negative 12. So that's what I break this up into now. Remember, they have to multiply to give you AC, which was negative, so we know that these signs have to be opposites. That's why 6 and 4 doesn't work in this case. GCF for the first one is W, 3W plus 2. Over here, negative 4 gives you 3W plus 2. Dang. All right. 3W plus 2 comes out. W minus 4 is left behind. There's one more thing I need you to look at. Okay, there's one more thing, and it's just simply the square of a sum. It's the reverse rule of what we did. Please, over the weekend, you have a little bit of time, just simply watch this video. There's only like 2 examples for this total. Watch them, take notes. What's due on Monday? Okay, good. And Tuesday, your homework for this is due. So this homework is not due on Monday. Problem set's Monday, this homework Tuesday. Questions? Okay, we review on Monday, so please come prepared with questions on Monday for the overall section. This is a shorter test, you're going to tell right away, right? Okay, also keep in mind that next Friday, you guys need to make sure to have your project ideas for optimization. That's what I really want them, Bob.
Monday?
Next Friday. Or Thursday, really, because Friday we don't meet. Sorry, Thursday, let's say.
Mr. Hall?
Yes?
Can I meet with you on Monday? What's the free period?
Yeah.
Because I can't meet after school.
Look, I'm not here after school today, actually, so that works out fine. But
No,
you
but
could.
on Monday.
Okay, so yeah, look at my schedule, see if I'm free the same period you're free.
Okay.
And just shoot me a quick email, that's fine.
Thank you.
You're welcome. Gus,
Yes.
this was lab we started yesterday, it's a pet lab. So you can do it on your own. It's really simple, we'll see. You gotta do that thing on PC though, lab science, it doesn't work. Okay, a lot of these guys are it's called energy skate park. There's a basic one, and then the regular one. You can do the regular one. Is Lucinda? Did Lucinda come today by any chance?
She didn't come in. She didn't.
I know she didn't come normal. She didn't come today, right?
I didn't see her.
You didn't see her? Alright. Her lab still.